Hello, grade 10. This is Mr. Ahmed, your physics teacher for today. Today, we will revise what we have taken in this quarter. So, we talked about Newton's law of motion. So, we have Newton's first law and second law and finally third law. Okay, let's revise. Newton's first law says that every body retains in its state of rest or motion in a straight line with uniform velocity unless acted upon by an external force. So, what is that meaning? This means that anybody, if we have, say, a book on a table, will stay in the same position unless you move. That seems very logic. We have anybody, any object like a book on your table. This book will not move unless you keep it up. Okay, so Newton's first law is called the law of inertia. So what inertia means? The inertia is the tendency of anybody to resist this motion or to resist what will happen if we have an external force upon this body. So, what make an static body keep static and what can we do to move it? Firstly, if static body keep it like the book we talk about, the static body have two equal opposite forces acting on it. First, the force of gravity and second, the force that keep it on the table. These two forces, the sum of it is equal 0. Total or sum of these forces equal 0. So the body will be static at this position. Okay, and this summation of F that equals 0 is called the mathematical relation of Newton's first law. Newton's first law called law of inertia, and the mathematical relation of Newton's first law is that sigma F equal 0. And sigma F or sum F equals 0, that means that the body is in equilibrium. And to break this equilibrium and make the body moves in any direction, we must apply an external force that cut this equilibrium. If we grab or took this book away, so we acted by external force that make the total force will not equal 0, so this body will move then. And the same, if we have a moving car with straight or uniform velocity, if we have a moving car with uniform velocity, it will not stop or accelerate unless we accelerate or decelerate. Then we applied an external force to decelerate it or accelerate it to move with non-uniform velocity or an acceleration. Okay, so to deeply understand this, let's take some examples. So, when a bicycle rider stops pedaling, it decelerates and comes to rest. Why? That when bicycle rider stop pedaling, so the force moving by the bicycle stopped. We stopped giving the car more force, and the frictional forces act at the opposite side of the direction. That will be the only one acted on the bicycle. So when the bicycle was moving like this, we have a force of pedaling. So when this force is cancelled, so we have the friction force. Friction force always acted in the opposite direction. So total force acting on this position will be the friction force with what will take this bicycle to come to rest finally. Okay, so the velocity at final will be zero. Okay, so the mathematical relation or the mathematical formula we talked about in Newton's first law that says sum of the force acting on any body in static or moving with uniform velocity equals zero. And the other meaning we talk about the inertia. The inertia, we talk that the inertia is the tendency of the body to keep its state of rest or motion in a straight line with uniform velocity. So, the inertia says that it's easier to move a body as a small mass than a body with as greater mass. So, the inertia depends on the mass of the body. So, if the body has a larger mass, so it has a larger inertia. Okay, so let us practice more with some examples. Okay. Now we will choose the correct answer. Newton's first law is called law of, as we remember, we called it law of inertia. Okay? So, in the absence of resultant force acting on a static object, if the object is static and the resultant force acting on it is absent or equal zero, so the body will remain motionless if it's already in static. Okay? So, number three, if the resultant force acting on a moving body with uniform velocity in a straight line is zero. So the object, so if we have the resultant force acting on any body equals zero, so the body will be in the same state. This body was moving, so it will still moving or keeps moving with uniform velocity. There is no acceleration until the total force acting on it will not be zero. Okay, so after that we have if the resultant force affecting a moving car is zero, the car will. Think about it for a second and say that the car already was moving. When a car is already moving and the resultant force acting on it is zero, so the car will move at uniform velocity or keep moving at the same first position. Okay? Then, number five, the law which states that the body tends to retain in its state of rest or motion unless unaffected by an external force. This is Newton's first law. Okay? Newton's first law says that the body likes to keep its state of static or motion. Number six, the mathematical formula that represent Newton's first law is that sum of F equals zero. Okay, and the last question we will talk today, an external influence that affects the object to change its state of motion or direction is called. From the meaning we talked about, so to change the position or the state of anybody, we need an external force. Very good. It's force. Okay, guys, was Newton first law for today, and we will talk about Newton's second law and third law laterly, inshallah.